So essentially for this unit, you need to memorize 4 formulas, and you'll be given the complex formulas. So once you know what the formulas are, you can just apply them to the different problems. So the general formula for Fourier series consists of 3 parts. Let me see if they give you the f of x in the general. No, they don't. Okay, so in a Fourier series, this is how your answer will be like, essentially. So your final answer will be in this form, depending on the problem, but a naught over 2 plus the summation of k equal to 1 going to infinity of the quantity a sub k cosine of k pi x over L plus b sub k sine of k pi x over L from negative L to L. Okay, so this is so essentially if you have a graph that's a periodic graph, the equation that you find here is like the equation for that graph, because a periodic graph consists of many different parts, right? So it's hard to get one general equation. So you use this. So this has 3 parts: a sub naught, a sub n, and b sub n. This is a sub naught, this is a sub n, this is b sub n. Okay? And each of these have their own formulas. A sub naught is 1 over L with the integral of negative L going to L, f of x dx. Generally, you can do 2 and 0 to L. A sub naught is 1 over L going from negative L to L of f of x times cosine of n pi x over L. This f of x comes from the periodic equations that you write, like with each interval, so not this final answer. Dx with n's from 0, 1, and on. So that's your a sub n. And then you have your b sub n, 1 over L, going from negative L to L. Of f of x, sine of n pi x over L dx. Okay? So if you have a periodic function, you need to find all these 3 parts, put them into that final equation f of x, and that's your equation for the periodic function, or the Fourier series. Okay? Now, what ends up happening is that we have even and odd functions, right? So for even functions, essentially you can do this for all periodic functions, right? But for even functions, it just happens so that b sub n always equals 0. Okay? So if you know that you have an even function, such as cosine, I think cosine is one of them. Is cosine an even function? I think it is, right?
Cosine of negative x is cosine.
Yeah.
Sine of
Yeah. So if you have a cosine series, then you know it is an even function, right? So then in your math, you only need to find a sub naught and a sub n, and then put that as your answer with the format of f of x. Okay?
So whenever we see cosine as a function, we just do that.
If you realize it's an even function, and yeah, cosine will be even, but your problem will be a bit more harder than that. Yeah, because you can do b sub n with it. You put say cosine of x here, but then your answer will come out to be 0. So essentially, if you know it's an even function, you just need to find a sub naught a sub n. Did that make sense?
Yes.
And then if you have an odd function, such as with sine, your a sub naught and a sub n come out to be 0. So then your answer consists only of b sub n. Okay? So for if you have sine, you do the math for a sub naught is 0, for a sub n is 0, but for this you'll get an answer. Okay? So just aside from cosine or sine, if you recognize that your periodic function is even or odd, you know which one to go directly. Okay? So if you have a periodic function, and I think this would be an example, that's like that or something. This is what? Odd or even? It's odd because it's with respect to the origin.
So an even function would look like a v.
Yeah. So, because it's symmetrical with respect to the y-axis. Okay.
So that makes it.
So this is even.
Okay.
This is odd. Right. So if you have this for your problem, what do you need to do?
Just find b sub n.
You just find b sub n. Okay. If you have something like this, or like a parabola, or something that's even or something, what do you need to find? A sub naught and a sub n.
What's the like if they give us the graph, how do we determine whether it's odd or even? Because I bet they're gonna give us a really complicated one, not like really easy ones like these.
You look at the period of it, like the repeating part, and then you see whether it's symmetrical to the origin or to the y-axis. So this is the old exam, but I'll show you. So I'll put up this on Blackboard, but I can still show you guys. Is this odd or even?
Even.
This is even because it's symmetric with the y-axis. Okay.
Y-axis.
It's symmetric with the y-axis, so it's even, right? So then the equations you use are the first two. Okay.
Symmetric with y is even. Symmetric with origin is odd. Or no?
Yep.
Yes.
Yep.
Origin is odd. Oh.
And that's with sine or cosine. Odd is no. Cosine is even, sine is odd. Okay?
I like numbers. I do like cosine of pi before and cosine of negative pi before.
Because if you draw sine,
I understand.
I don't. I just
sine is an odd graph because it's symmetric with respect to the origin. While cosine is even because it goes like that. Yep. So essentially, that is the hard part of this unit, because once you know which formula to use, you just need to simplify it or do the integral and stuff. Like, you would need to solve out this integral, and all of them essentially, I believe, involve u substitution.
Yeah, a lot of them have an integration by part.
Integration by parts, really? Okay.
Could
So-
you explain what they did in class, like where we had to fill in the intervals? They gave us like part of an interval.
Okay, we had to do this little graph thing, and it was like this little
Yeah,
piece-wise graph,
that's
and that's how we found out whether it was even or not.
And it was so cute, Dr. Tyler, that was like his time machine. Where he like could go to the
that's not that important as long as you see that the graph is even or odd. I think I have that in my slides. I'll go over. Because when they do the math for you, it sort of is confusing. But if you can see, look at the graph and know the answer.
How do you like? Can you explain like how to know when it repeats and like where to put it?
What do you mean when it?
The
I'll.
examples that they did, I didn't understand how to like.
I have the examples that they did, and we can just go over them. Yep.
How do you, they'll always give you the period, right? Or will you have to ever, we ever have to figure it out?
Sometimes you do need to figure it out.
No,
Most of the time, they do.
there's always two, even though he told me it's not always two.
I got a 4 one time.
Oh, watch out.
I think your L was.
Yeah, my L was two. My L was always two.
Yeah.
And I did.
But essentially, the only thing I can recommend is that you just do a few problems that teaches you how to simplify, and all the problems will be similar to that. Like, if you do like 1 or 2 problems, essentially you've done all the kinds of problems with this. Just the number, like the limits will be different. Okay. So we have f of x.
I liked it, but I don't know what was wrong with it.
Is that the same graph that they do? Oh. F of x is equal to the integral of x from 0 to 3
Interval.
and negative 2 from 3 to 6.
Where's the shirt? Is old school,
So for the first one, I'm not exactly sure what they gave you as a given, but I have here for part A of f of x that is periodic.
What did you say you're doing?
Periodic.
No, before that, you don't know what.
Like I have it all my answers, so I don't know what they gave you and what you had to figure out.
We could tell you.
Um,
I tried to find out something easy.
That looks like the
Well,
final
yeah, this
answer.
is what they gave us, and then
Oh, okay.
they asked us to go from -3 to 0, and then -6 to 3.
okay,
Is this,
I believe I have that.
is this a test question? I feel like where they have you graph it and stuff.
It was-
The test question is really, really easy.
Wait, so
Like-
they gave you the
They're
interval
usually
at the
want
top, at the top,
I
right?
can give you the
Yeah.
difference
I
line,
did
it's
like
color
two,
coded.
but I was like.
No, I think I got it. If I don't, I'll ask. So it's from -6 to x to 3, -3 to x to 0, so 0 to x to 3, and then 3 to x to 6. So you have to find the equations governing at that point, right? So we can graph this and see what it looks like. From 0 to 3,
Is there supposed to be a negative sign in front of
from
the top three?
one second.
Is it her?
It was my dad.
It was your dad?
Yep.
Is you?
Okay.
Okay,
Yes,
that's
he's
the
gone. Yeah. So
Here it was.
we're going to 3.
Are we going to 6? Oh,
Well, the whole thing, but I'm just -3, -6, and then 6. So we can graph this, and that shouldn't be hard. So from 0 to 3, it's like that, -2. From 3 to 6, it's -2, right? So if it's a periodic function, this pattern repeats itself. So then from 0 to -3, it's a -2, and then from here, it's like that.
Did they just tell us it was periodic? Like, isn't that what we're supposed to find out?
In order to graph it, you are told that this is periodic.
Which means just repeat whatever
Yeah.
already happened.
So you already saw this part from this that you were given, f of x, right?
What would the period of this be?
The period of this, it would be
You're like half of it. Yeah.
from -3 to 3.
Why couldn't I just make it -6 to 0?
-6 to 0. It's just, I feel like they always do it half and half from the y-axis.
Okay.
So then
Yeah.
like if it's like odd function, it looks like a
Like the sign
symmetric with the origin and sort of thing. So it's every problem I've done, I believe it's from a negative number to the other side.
So this is neither even nor odd.
What? No.
This is just periodic.
Okay.
So then you have to write down the equations for each part, right? So what is the equation from -6 to -3? What?
X plus 6.
X plus 6. Okay. From -3 to 0, -2. And then this was x and this was -2. Okay. So you have a problem like that, but you are given the graph and everything. No, you're told to draw the graph by knowing these two. Okay? So just like in this problem, I looked at these two, I drew these two portions of the graph, right? And then I knew if this was periodic, that's how it would look. Right?
Do the next one.
So the next one, they tell us it's odd. So we still draw the first top with this governing on the right side from 0 to 3. And then -2 from 3 to 6, right? And they tell us it's odd. Now, what is odd? It's symmetric to what? The origin. So if we are to make this symmetric to the origin, what would I draw here first? You would extend it going down like that. Okay. And then what else would I need?
You would like flip that.
+2. Okay.
Does he want us to show, like, does he want work for that, or does he just want us to graph it?
Just graph it.
He like did.
So he was doing all this like complicated stuff.
We'll get to that. That's to find the equation for this part. And it's not really complicated because they try to get you to think using the formula, but essentially you can look at the graph and know the equation. So for an odd, though, f of x of -x, or f of x is equal to -f of x, right? So
Wait, so did they say
Isn't it
it's
f
odd
of
or did they
negative x
give you
equal to
They'll
negative?
give you this notation here.
what?
f of x
Equals.
Say that again.
That's odd.
I thought it was f of negative x is equal to negative f of x.
It is
F
that,
of
actually.
-x.
Yeah, this is even. Sorry.
You should go
That's
through the.
nothing.
That's nothing.
There you
There
go.
we go.
You
So
should go
this
through
is
the
odd.
notation and then let people know that we'll look up for it.
What?
The notation for like an odd even.
What is
But they're not
that?
gonna explicitly say even or odd. They're gonna have like f of o x, which is the odd.
Oh,
Because it
Okay.
crash because there's some people.
There's something easy that's like
It looks pretty cool.
Yeah, they put a little o under the f.
did that? like that.
No, not for that, but for like, when you're doing the piecewise or the
Like where the piecewise is?
Yeah, so you put an O for that O, like, no, those are fine, no, just get rid of those O's.
This O? Well,
No,
in
no.
my notes I have O's here, so I'm putting them there.
Those O, that F right there, that's the big one.
Here?
Yeah, that's it, that's
Oh,
what
here?
O, yeah,
Oh, okay.
so that's what it means high.
Sure. If they, I don't think they would care much about it. I've never had a problem where they require you to show that.
No, I mean, that's what tells
But-
you it's odd or even.
Yeah. So if there's an O there, that means you're looking for the odd graphs. Okay. But that's not that important. So for this period, -6 to -3, what is our equation? 2. So they did this a little bit complicatedly. Essentially, I see that it's a 2 in the graph. We can put a 2 there. But what they wrote in was -2. That's what they did.
-2.
Because originally it was a -2. Okay. In the not the odd function graph,
The original.
the original graph, it was a -2 here. So then
the thing that we did.
a negative of that, looking at that, essentially gives you a +2. But I don't even care about that. I just look at the graph. And that's what I would say to you guys.
No, I think it
Alright.
So then, what is from -3 to 0?
X.
It's x, right? What they did was negative of -x equals an x. But in the graph, you know it looks like an x. Okay? So then we already know this part though, x and then -2.
Inside the parentheses.
The inside the parentheses one?
Mhm.
It's because something to do with like how it's a -x here. But again, I said don't worry about that. Like I'm actually not gonna even write that in. Because when they tell you to write the formula for the graph, like on the old exam they do that, you can just write 2 and x. Yeah. Okay. Do you guys get that? Like, don't worry about the math that they showed in class. If you just look at the graph, you get the equation for it. Don't forget like the x or y intercept, sort of, like in the last one we had x + 6. So let's quickly do the even one. The major part is knowing what it will look like once you do the graph. So if this is even, that means it's symmetric with what? The y.
Y-axis.
So what will it look like right here?
It's gonna go like an absolute value.
Like that, right?
A V for victory.
And then this will be on this side right there. Okay?
Is it Papa John?
Hello? Yeah. So Ernst Haller? Or Ernst Haller? Ernst Haller?
At U of L. Okay, you go take care of this. Thank you. He's getting pizza. Yeah, for us. Yeah. Oh, I'll get on the video. Ooh.
I thought you were getting fired.
What? I'm not gonna get him fired.
It doesn't matter because this is his last session.
Last sentence.
I'm on.
I don't think I need my computer.
You know, but the way he was talking on the phone, I thought it was a girl.
It might have been his girl.
She's like, really hope it's girl. I was like, Top John, is this you?
How do I know whether this is on or not?
Don't mess with it. You're messing with Daniel Good. Get him. Get him.
Is that sarcasm?
Cookie's coming. Get down.
now, it'll start seeming a little good.
Yes, sir.
You're gonna scrub.
Okay. Oh, wait.
I didn't do anything. I was just
These are growing like fun pieces like that.
Did they really not figure out where 216 so far was this? Have they ever heard it repeat it?
Actually, say something.
Huh?
Okay, so I'm gonna go get the pizza there at Deli.
Okay.
But
Why are they gonna do
Do you need to pause the video?
no, it doesn't really cost. Can you just write that equation? You guys know how to do that, right?
Yeah.
Yeah.
Like,
I can
No,
make
I was
that
like, I
sign.
could, but like, I don't know what's going on with it. Jenny, you know how to do this?
Well, that was it.
This is
I'll in the video that I'll be back.
Okay, go Jenny.
Go, Jimmy.
Go Jenny.
Go, Jimmy.
Well, I'm gonna have to erase some of your parts.
You can like erase around the word.
It's Jen.
It's Jen. Oh yeah, Jen. Sorry.
Go, Jen.
Go Jen.
Yikes.
Go Jen.
Tire me from.
Yeah, we are now teaching.
Where's his chalk?
The chalk's in the big box on the right.
It's all small chalk.
Oh, yeah, that's all they got.
So this is at -2.
Great.
So this is -2. And then this looks like -x. So it's -x. And then these two are already right because this is just the equation for x. You should know this. I'm making you proud. Oh, are you back?
I have to get my wallet.
You guys are making hand sanitizer?
This is cheap forever. No, I'll give him money.
I'll be back in a second.
I will chip in. You ended the session.
No, it's fine.
Oh, should we try and? I don't know the unit well enough to teach it.
That's not true.
Okay, go look. Go look, Reese.
Until you get to the complex stuff.
Go look, Reese.
Objective power.
Do you have any? Is this our last draft for this part?
Yeah, that's it. That was it.
Okay, so what do you want to
Part
do
is pretty easy.
But that's not really anything important. There's a tiny graph like that.
Do something.
The stuff on video was okay. The stuff on video was
See stuff on video. Or did you want?
no. It was Is even odd is what we're doing here, just with sine and cosine.
We'll do something else. I didn't watch. Oh, I totally watched it. Just in case.
There's literally nothing.
Well, why don't we do an example, just a whole example?
You have so much fishing. I can't believe that they I like Rockaway. I like his like theory of like and that's
Yeah, I think I'm gonna tell them that after the end of chapter and I talk to them about it. I
just
think
ask
it would be
why,
an incentive for people to work harder, maybe.
which I completely understand. Like if you like need to pull through very like the echoes.
Yeah, not like, oh, you still have to take the final, you still might screw up. And if you have an A in one of the, I think they should do it where in the calcs you have an A.
That's not fair though.
Yeah. What?
Because the exam is worth 25%.
Yeah, no, but you don't have to take it. So you just, if you have an A in the class, you get an A.
But it's how people really put in so much work.
It's just,
to
you
get
have, it's not a
everything.
rated class where you, well, Rockaway does, you only have 4 exams. And
Yeah.
makes fun off, but what we have 15 exams.
Well, just because you know how to do an exam every week doesn't mean like
I mean, if you've been if you've been tested 15 times during the semester and you've like managed to keep an A, then I think you know the mystery.
but like the thing is you only have to know it for that week and the week before. So
That is
I mean,
true. That is true.
so you
I
can
mean, yeah,
you can
but
forget
like,
it.
So that's
This
what
is
they'll say to you. They'll be like, "Hey, well, we want to make sure you."
I mean, this is like
the
beyond
material."
overkill. No other class even.
I mean, I don't think that they should have a test every single.
Well, that's my point is if you're gonna do, I was like, there is no other class in this university or most universities that even touch the amount of examinations you do. There's 15 exams a semester and a 25%
No,
final.
I understand, but
And
Jenny,
homework
but
every
Jen's
week.
right. That's exactly what they're gonna
That's
say to
obviously
you.
what they're gonna
That's
say, but
exactly
I'm
what
just
they're gonna
gonna
say
be
to
like.
you.
All right,
I'm
guys.
like, I know the material.
So any questions on this stuff? So let's try to finish quickly.
Okay.
Oh.
Thank you,
Okay.
Daniel.
So then there's one last part. It's the complex exponential Fourier series. And they give you the formulas for this.
And do you only have that C? Like, you don't have anything else, right?
You have C naught and Cn.
Do you have like an example you could work through?
Yeah. Find the complex exponential Fourier series for this periodic function.
Yeah.
They would, it's very different.
That's true. They
They would, if they actually wanted us to learn the material, have us memorize it for a week. I just don't think it's fair for someone to be consistently like, I've done all of this. I shouldn't have to do a final and then sign it.
Well, like the point is that they had to see an idea is, well, I would study harder and work so that they well, so and also the chance for them.
And some people just believe that more always needs to change.
Yeah.
I think this is what you guys did in class, right? Okay, so we have to do find the complex series. And they told you that the periodic, or no, what is the period of this? What is the period of this, guys?
2.
Period is 4.
Oh, it's that too.
But what is that? Isn't that L2?
L is 2. So L is generally like that. So L is equal to 4 over 2. Okay. So then C naught, they'll give you this formula. Yeah.
Does a period indicate like that's the number that it repeats itself like every 4?
No, that's the limits on the pattern completing one rotation. And then L is just half of it, since it's essentially symmetric.
So it repeats itself every 4 values?
Okay.
And will you get in the C sub not C not?
Yeah. For complex, you're given all the formulas. For the other stuff, you're not. So with that, essentially, we just fill it in. So 1 over 2 times 2 is 1/4, right? So going from -2 to 0, we have the formula, the f of x of 0 dx, plus going from 0 to 2, our f of x is 3, so we have 3 dx. Okay, so then 3/4 x going from 0 to 2, that is equal to what? 6 over 4, which is 3/2. Okay. So then we do C sub n.
And they give you all of this?
Yeah. C sub n is equal to 1 over 2L, going from -L to L, f of x, times e to the minus I n pi x divided by L dx. Now this is what I meant. It's good to do like 1 or 2 problems of every type, because then you know how it should simplify out. Because then you know whether you need to do U or integration by parts and stuff. And this is when n is equal to plus or minus 1, comma, plus or minus 2, dot, dot, dot. So n cannot equal a 0. Okay, for that part. So for that, we get 1/4. Now the first one, I'm not going to write because, again, if we have a 0 here, it's going to go to 0, right? So it's 0 plus adding in with the 3, so plus 0 plus the integral from 0 to 2 of 3 times e to the negative I n pi x over L dx. And L is 2.
So it's always gonna, the end's always gonna be like not equal to 0 there.
Like this 0?
It's always gonna work out. No, the 0 with the end, you know, you said n can equal 0.
Yeah.
So it'll always work out. Like, there's,
That's just one of the rules. Like those are the limits on C sub n. So then we have to simplify that. That's equal to 1/4. Essentially 3/4. Why do they not do it as 3/4? Oh. Times. So if we do then what's the integral of it, right? It's e to the x over x or dx, right? That's not, like, what is the rule for e sub x?
UDU, right?
Yeah.
I don't know.
You okay?
What is it? It's e to the u divided by du.
yes. No,
What are you doing?
what are you talking about?
The integral of e to the u.
It's
It's just
e
e to the
the
u. E to the x is e to the x, e to the u is e to the u.
It'd be
You just have to do a u sub. You have to multiply it by.
U is negative I.
Yeah.
Oh,
I.
So you multiply it
So
times
yeah,
3
you
I
do
and 5 or 2.
I believe you flip it.
you flip it. That's what I'm
Yeah.
trying to remember,
But
like the
that's the
actual
b.
formula.
It's negative 2 over pi ri.
Yeah, but like, what is exact? I don't remember.
Oh, I don't
but-
remember.
okay.
I just memorized
It's
the
just a flip of
You
it.
just have
so
to get
it's-
a du, and so without the du, and you divide, and then you divide by whatever you had to do.
Yeah. Essentially, you divide by what's in the top, so then it's flipped upside down there. Times e to the negative I n pi x over 2, going from 0 to 2. So we don't really have space here. We get a negative 3/2 here, right? We'll just make that common.
Yeah.
Adding a 2 here, or a 2 there, we'll take that out. So we have negative 3/2 times I n pi oh, there shouldn't be an x there. I n pi times e to the I n pi negative I n pi minus e to the 0, which is 1. Okay. Do you guys see how we got there? That's like the important part. And then we also want to bring the I to the top, so we multiply.
You multiply by I over I.
Yep. I over I.
You don't want the I.
We don't want the I in the denominator exactly, so we do that. Do you guys have that copied? Yeah. Yeah, it goes away. We still need to know that our C sub naught is 3/2. So then our C sub n is equal to 3i over 2n I squared, right? So this is n I squared is equal to -1. So then this becomes a positive, right? So then I will rewrite that as a positive 3/2 I over n times e to the negative I n pi minus 1. So now we put it in the actual formula for complex, which is f of x, all right here, equal to c sub naught plus the summation of k equal to negative infinity going to infinity where k cannot equal 0 of c sub k times e to the I k pi x over L. Okay, so then our f of x is equal to 3/2 plus 3i over 2n of 3i over 2 because n goes inside. I forgot a pi here. So 3i over 2 pi.
Do we need to remember all? Like
This formula?
Yeah.
For complex, it's given to you. For the even and for the normal Fourier series, you have to memorize. So then it's the summation of k going from negative infinity to infinity, where k cannot equal 0 of c sub k. This is our c sub k. That's why I had the constants be outside here. So then I have e to the negative I n pi minus 1 divided by n, which in this case now is k. So this is negative I k times e to the I k pi x over L, which was 2.
Where did you plug? Okay, so the formula. Where do you plug in the e stuff? Like, is that being plugged to a variable, or is that just the formula itself?
Say that again?
So you plug the e in the formula. What is the original formula for this look like? Is it like what is? Where do you plug in the e? What variable you plug in for? C sub k.
Yeah, c sub k is what we found here, c sub n.
Okay.
Because n is equal to k. We just use k in the summation sign. So then there's lots more to simplifying it.
How do you say we could do it like that? That'd be fine.
We have to change now e sub. They don't give this to you, but you should know that e to the I n pi. Is it? Sorry. Yeah. Or in general, e to the I n pi is equal to the cosine of n pi minus I sine of n pi.
No, they just did it.
Yeah. So this is something that you need to know. Okay. So in order to simplify this, we need to make this substitutions. Is it e to the negative I n pi?
No. E to the I theta is cosine theta minus. I think that's right over here.
Did I? So it's right what I
And then
wrote?
and then I think if you plug in a negative, then you make.
So do you
Oh, no, it is.
It's
It is negative.
Yeah.
Because normally it's a plus, so that means you put
This is
negative.
normally a negative up here.
e to the negative I.
Normally what it is
Okay.
e to the I pi block. And you
Yeah.
have cosine plus block.
Yeah. So when it's a negative I up here, it's a negative I here. So we need to make that substitution right there. Okay.
You don't think you can ask a little test to check ourselves too?
What?
You don't think on the test is gonna like because what they did in class like this is that they did it to basically verify that it was true. So
No,
now
we
we
don't
don't
need to do that.
you don't think I would do
They said we didn't have to.
Okay.
They, he was just showing
They
us
were like, you don't have to.
he said to build our confidence.
Okay.
Because how would we change that, like, that formula, what is e to the I k pi x over 2?
We keep this the same.
We left it, yes.
because we wanted in that summation, like that part stays the same. So we'll get there. So plus 3I over 2 pi summation of k from negative infinity to infinity, where k cannot equal a 0. So now we have 1 over k times cosine of k pi minus I sine of k pi. And then we still just keep the right portion. That stays like that. And they actually give you that formula.
Wait, so do we need to do this or not?
You don't need to memorize this.
Box, this box.
This is what they give you on the exam. It's the positive. So they give you this. Okay? So they give you a lot of stuff for that complex problem. They give you that, but you need to know, since it was a negative I, this is a minus here. Okay? So we made the substitution. What is cosine of k pi?
Depends on negative 1 to the end.
Negative 1 to the n. That's how it alternates with the k values. What is sine of k pi? Always 0. So then, oh, I forgot the minus 1. We still have a minus 1 here. Okay? So then, this portion becomes negative 1 to the n minus 1 divided by k. Or this actually is a k up here. Okay? And then we just rewrite everything. Going from negative infinity to infinity, where it cannot equal a 0. So this would be your answer. Do you guys understand all of that? Because they give you the formulas, it's just simplifying it. And that's why I said if you do like 1 or 2 problems of all these types before the exam, you should have no problem doing well on the exam. Because you've seen all the different ways to integrate it simply. So any questions on this? What? Yep. So that's why I don't think this unit is actually hard. Because for this complex problem, they give you the equation essentially. You just need to do the integral and simplify it for 4 years. With you just once you memorize it, that's the only hard part. If you've done enough of the problems, you should be able to simplify them.
How much room does it take up all this notes?
For this problem, it is
Their last test was like
half a page.
almost 4 problems.
It's half a page.
C sub 0 and C sub n, are they similar at all? Like if you have, what often happens to me is I just like completely forget the formulas I'm supposed to know. Is there any way, are they similar at all? So if you do forget that, they could be like a starting point.
For complex, they give it to you, but C sub O and C sub N are the same except for the e to the I n pi x over L. Except for, I don't have it up there. But that integral just had that extra e part. So they're the same except for that very end.
Wait, no. Like A sub n and A sub 0, are they similar at all to C sub n and C sub 0?
A sub n is
Wait, I have
A sub n is just 2 over L and then f of x dx, right?
it's 2 over L?
Yeah. Or sorry, Yeah, it is 2 over L. A sub naught is 2 over L integral of f of x dx. A sub n, you have the addition of cosine of n pi x over L.
Okay.
B sub n, you have the addition of sine of n pi x over L.
Okay.
So that's the
Copy
difference.
that, yeah, that's pretty good.
And the review sheet also has them there, so you can try to see, you can memorize them. Otherwise, that is it. I hope I wasn't confusing at the end.
That's all. That was pretty good. That's pretty good.
Yeah, I didn't do like the whole entire problem with even or series.
Yeah.
Do you guys want me to do one of them?
Like with the sine cosine? Objective
Uh,
four?
One, so sine and cosine, you only use a part of them, but an entire periodic function, you need to do all of them. If I can do one with all of them. Yeah, let's do that. All right, let's do this problem. Are you guys good to do one more problem?
Yeah.
It will probably take like 30 minutes.
Wait, for real?
Up to you guys. If you guys don't want to, it's fine. There's pizza there. Okay, we'll just end the session.
I mean, yeah, we were the first class.